everyone, Shannon here, and this week one of the topics we're covering is data engineering, and joining me in this topic is my friend and colleague Atma Mani. Now Atma, what do you do here at Esri?
I'm the lead product engineer for our GS API for Python. I'm very passionate about solving geospatial problems with Python and ArcGIS. Data engineering is an important initial step in the data science process. It is the phase where we collect and clean data so it can be modeled.
So you may have noticed that the real world can be a messy place, and so is the data that goes along with it. We can have missing values, outliers, wrong data types, and the list goes on. In fact, most analysts and data scientists will spend most of their time cleaning and wrangling data, what we call data engineering.
In traditional data science, we call this feature engineering, not data engineering. That's because in the data science world, features refers to the columns or attributes you would have in a data set.
But in GIS, the term feature has a totally different meaning. Basically, features are the points, lines, and polygons that make up your spatial data. They're the parcels, the line segments, the points of interest, the event activity, such as crimes. In GIS, all of that is features. So, we use the term data engineering to cover all scenarios.
Some common data cleaning steps in data engineering can be dropping duplicate or highly correlated columns and fields that are no longer relevant to the study. You may want to apply some scaling, normalization, or some other kinds of transformation to your data. On top of that, when you're dealing with spatial data, you may encounter a whole host of problems.
Right. I mean, if you're working with real-time data, you may have sensors that stop responding or become broken in the field, introducing gaps into your data stream. Or if you're working with batch data, you may have what looks like beautiful attribute information for addresses, but it turns out they aren't geocoded, meaning they're not tied to some real location on the surface of the Earth. Or worse, and I've experienced this one, they are geocoded, but it wasn't done correctly, and so now you have data tied to the wrong location on the surface of the Earth, adding frustration and noise into your analysis.
Data cleaning is one aspect of data engineering, and we have numerous tools and approaches for solving those problems. Perhaps one of the most exciting types of data engineering is geo-enrichment. In traditional data science, you may want to add new columns to your data set from additional sources to build more context to the problem that you're trying to solve. Geo-enrichment builds on this concept, and it allows you to find new variables based on the location of your data and add those to your data sets, even if there's no obvious ways of joining those different tables.
So imagine you're a retail store owner and you have a data set of all of the locations of your stores. And for each location, you have a number of variables, including store revenue, which you want to model. Now, for this analysis, you may want the socioeconomic and demographic information for the customer base of each store. Now, in a more traditional workflow, you may accomplish this by joining the demographic information to some known geography, such as a zip code.
But not everyone that's living in a zip code would go to a store, and neighboring zip codes would also influence the revenue of the store. So instead of using zip codes, we could get the socioeconomic data, say, from a 15-minute drive time around the store, and this data set would be more accurate and help us model this problem better.
Right, so how do we do it? How do we get the demographic information for the 15-minute drive time? I mean, we know that the data wasn't collected that way. What we want to do is we want to take the pieces of the relevant zip codes until we can create an accurate representation of the underlying population within that 15-minute drive time. Now, some people would take this for granted and think that it's just based on the size of the overlap of one zip code versus another, or that it's just some simple division. But it's not.
No, it's not. Geo-enrichment allows you to take that 15-minute drive time polygon and apportion the socioeconomic data to this based on the underlying population data. So overlaps that have more people, not just more area, would have more influence on the outcome.
Now this week, you will get to try your hand at cleaning up some messy data, and we'll get to learn how to use geo-enrichment to add context to your analysis.